Hi, welcome back, dear students. Today we are going to solve the next exam. It is October-November 2024, Paper 2, Variant 1, IGCSE Physics. It's MCQs, 40 MCQs, and you will have maximum 45 minutes to solve. So let's start this paper. Question number 1. A student uses a meter rule to measure the length of a sheet of paper, which measurement is shown to the nearest millimeter. Nearest millimeter means it could be a whole number of millimeter. It could be 1 decimal place of centimeters, or it could be 3 decimal places of meters. So you can check in this case 3 decimal places of meter, 1 decimal place of centi, or 1 millimeter. Why? I will teach you. Because 1 millimeter, if you divide by 1000, it will change into meters, which is 0.001 meter. So nearest millimeter in meters has to be 3 decimal places. So only value in meters, which is 3 decimal place, is option B, because it is 3 decimal places of meters. Let's go to question number 2. Question 2. A rocket travels with an average speed 6 kilometers per second in 2 minutes. So 6 kilometers per second is the speed. You can say letter V, and the time is 2 minutes is T. You want to calculate distance traveled D. You all know that distance traveled is speed multiplied by time. Since your requirement is in kilometers, all options, so you will not change the unit of speed. You will keep it in kilometer per seconds. So what you have to do over here, 2 minutes, minutes you will change into seconds. In order to change minutes into seconds, you multiply by 60. So your time will be 2 multiplied by 60, 120 seconds. So what you have to do, the distance will be speed, 6 kilometers per second, multiplied by 120. 6 times 120, it is 720 kilometers, the option C. So you needed to change minutes into seconds. To change minutes into seconds, you have to multiply by 60. Let's proceed to question number 3, my dear students. The diagram shows a vertical force which is acting on a ball as it falls vertically through air. The ball does not reach terminal velocity. Which row describes what happens to the resultant force and what happens to the acceleration? Here is the concept. So as ball falls, its speed increases. And when speed increases, the air resistance, which is opposing the ball, also increases. When air resistance increases, the resultant force acting on the ball will decrease because more and more force is opposing you. Since you know acceleration is proportional to resultant force, so acceleration will also decrease. So from here, you can choose the resultant force decreases, so the acceleration decreases. The both decrease, the option is A. It's a very good question. Terminal velocity is a later concept. At terminal velocity, acceleration is 0, but they did not ask you over here. The next question, question number 4. A coconut falls from a palm tree. At X, it has just started to fall. Y is point just before it hits the ground. So X is initial and Y is final. What is the acceleration of coconut at x? So when it starts to fall, so this acceleration is the free fall acceleration, which is equals to g. And it falls to the ground. They say air resistance is negligible. When air resistance is negligible, what does that mean? The acceleration of free fall is constant. So whether you are at x, acceleration is g, you are at y, acceleration is g. Because the acceleration of free fall is constant, so it will be same at both points. Right option is C. We proceed to question number 5. A car is driven round the bend in the road at a constant speed. Direction of motion of car, you can see, is that way. What is the direction of resultant force on the car when it's going round? Whenever a body is moving in any circular path, the resultant force acting is called centripetal force. And centripetal force acting on any body when it's moving in a circle is always acting towards the center of circle. So right now, if the car is moving in that way, so it means the resultant force will be this way, which is perpendicular, So perpendicular to the motion, 90 degrees. Parallel, no. Parallel, no. Two options are crossed. Perpendicular to the motion, yes. And towards the inside bend, yes. Option D is perpendicular but outside is the wrong option. So correct option is C. We proceed to the question number 6. The diagram shows drawbridge that is attached to a wall by a hinge at one end and cable at other end. The weight of the drawbridge is and the tension. The weight and the tension are represented by the arrows. Okay, now they say there is a third force at the hinge which is not shown. The drawbridge is in equilibrium. Now you have to highlight the term equilibrium. The equilibrium means resultant force is 0. So if the resultant force is 0, so this should be cancelling both of them. So to cancel its left component, the force should be to the right. To cancel the downward weight, the force should be up. So if you decide you need to have a force to the right side and force up. So right is to cancel tension, up is to cancel weight, so the resultant could be somewhere between them to cancel both of them. So look which arrow looks like that. So the arrow which looks like that is only option D. The right, the top, D. Because to cancel the weight, there should be a force up. And to cancel tension, there should be right. So resultant force will be 0 if there is a force in this direction. So option is D. We proceed to the question number 7. Which equation gives momentum change of a body? Change in momentum, dear students, please keep in your mind, it is also called impulse. Impulse has two equations. Both equations I'm writing. One equation is mv minus u, and other equation of impulse is force multiplied by time. So look which of the equation is available, you choose that. Change in momentum force per unit area, no, that is pressure. Force multiplied by distance, no, that's the work done. Force times distance over time, no, that's the power. This is pressure. This is work done. This is power. And the last one, if you see, change in momentum is force multiplied by time, as I told you before, is the impulse, option D. We proceed to the question number 8. Which statement about the use of nuclear fuel as energy resource is correct? Okay, nuclear fuel as energy resource. It obtains the energy from sun. No, it's not from sun. It is the fission of radioactive isotopes. It has no environmental impact. Yes, it has environmental impact, like the radiation hazards, impact on farming, impact on social, like the people. So option B is also wrong. Nuclear power stations do not need turbines. They need turbines. They need. Why? Because nuclear fuel, when fission reaction occurs, it gives you thermal energy. Thermal energy goes to boilers, which produces steam, and steam runs the turbines, and eventually turbines runs the generator. So yes, we need the turbines also. Option C is also wrong. The energy is released by nuclear fission. I already told you the process is fission. So option is D. We proceed to the question number 9. Question 9, the diagram shows an object which is having mass m being projected with the speed v from a point P to a point Q with the height h. So it goes this way. So overall height is, change in height is h, which will be used to calculate mgh, the GPE. Okay, so what is the kinetic energy of the object when it reaches Q? Principle of conservation of energy we are going to apply. At P, it has kinetic energy. Total energy was half mv squared. But when it reaches Q, its total energy is the kinetic energy plus gain in mgh. If you equate these two equations, you will say initial kinetic energy is equals to final kinetic energy plus mgh. And if there is a resistance, yes, there is a work done against a resistance as well. So total energy is conserved. You rearrange to make kinetic energy the subject. So this will come here and this will also come here. You subtract them, half mv square minus mgh minus work done against friction will be final kinetic energy. So if you equate, which option is exactly like that? The option D. You subtract the work done against a resistance and also subtract the gain in GPE, remaining is kinetic energy. We proceed to question number 10. The diagram shows a Sankey diagram for electric drill. Energy input, okay, and this is the kinetic energy. This is called the useful energy, and these both are waste or loss. What is the total waste? So as I showed you, the waste total is sound plus thermal energy. So you make the calculation as per scale. Now look at the scale, my dear students. So they say the distance between two lines is 40 joules. So go here, how much is the total? So this one is 40 joules, you can see. This is 40, 40, 40, 40. You can say one line is here, and here total 4 lines. So overall will be 5 lines. The waste is 5 small lines. And each line they say 40, so 5 multiplied by 40, the answer is 200 joules, the waste. 200 joules is the waste, my dear students. Now we proceed to the next component. Question number 11. The elephant is having the weight 45,000 Newton, stands with all 4 feet on the floor. So weight W, which is actually the force, standing on all 4 feet. Okay, the average pressure on the floor due to elephant is this. This is the total pressure, P. What is the area of each foot? No problem. You know the pressure formula, which is force per unit area. So the area will be force over pressure. I'm substituting the total force first over total pressure, and let's calculate that. Then 4 feet we will divide it. So this comes to be 0. Sorry, the pressure is force over area, so area is force 45,000. So the calculation gave me 1.3235 meter square. Now this area is 4 feet. We need for 1 foot. Each foot mean exactly 1 foot. So you divide this by 4. The answer is 0.33. So option B. We proceed to the next question, which is question number 12. Now from here, general physics finishes, we start the thermal physics from question 12. Some air is trapped inside the metal container with tightly fitting lid. So lid is fixed. So the container is heated strongly behind a safety screen. The lid is blown off by increased pressure inside the container. So lid blows off. What causes the increase in pressure? So dear students, here is the answer. Whenever you heat anything, the heat causes two things: increase in kinetic energy of particles, so increase in speed of particles. When speed increases, the particles, they collide with the walls of container more often. So you can check which option is there. Each particle expands. Students, particles never expand. Particles never expand. The particles move more quickly. Yes, when you increase the temperature, kinetic energy increases, particles move fast. The option is B. We proceed to the question number 13. A very hot mug of coffee is near a large unheated swimming pool holding 2.0 10 power 6 kilogram of water. Which statement is correct? So a hot mug of coffee is near that. So if mug of coffee is tipped in the pool, the coffee will lose much more internal energy than water in the pool grain. No, my dear, the mass of water is much more than the coffee, so this will not take place. Internal energy of a substance depends only on the temperature. No, not only temperature. Internal energy is actually kinetic plus potential energies. Kinetic depends upon temperature, but potential depends upon the separation. So B is also wrong. Option C, internal energy of water in pool is lower than internal energy of mug in coffee. No, it's also no. So they say it was unheated. It is unheated. So unheated mean it has potential energy plus kinetic. Kinetic could be lower, but potential is more. So also no. When temperature of mug of coffee falls, its internal energy decreases, yes. Because internal energy is equals to kinetic energy plus potential. Potential will remain same, but when kinetic will decrease, internal energy will also decrease. The option D is the right option. It's a good question. We proceed to the question number 14. A student measures the mass of water in an open container over 2 hours. So if container is open, certainly the water might be evaporating. So evaporation takes place and water goes out, so mass of remaining water will decrease because water is changing into liquid into vapors. So initially mass is 33.9, then decrease, 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 decrease. So reason is the water is evaporating. Water is evaporating. Evaporation is the escape of most energetic liquid molecules from surface. So as the water keeps going, the mass keeps decreasing. Question 15. A 1 kilogram block of aluminum requires more thermal energy. So aluminum requires more thermal energy than copper. What could be the reason? You know thermal energy, E is equals to m cat, dear students. E is the thermal energy, so both they say 1 kilogram, 1 kilogram. And both rise with same temperature. So it means thermal energy is proportional to specific heat capacity. So if you read the question again, aluminum requires more energy. So if aluminum requires more energy, so specific heat capacity of aluminum will be more. So aluminum will have more specific heat capacity and copper will have less specific heat capacity. Let's see which option matches this. So aluminum has higher specific heat capacity than copper. More the specific heat capacity, more the energy needed to raise temperature. Option is C. We proceed to the question number 16. A block of ice is at a temperature negative 100 degrees Celsius. Energy is supplied at constant rate. The graph shows how temperature changes. So initially 100, temperature increases, reaches melting point, then water heats up, then water boils, then gas heats up. Okay. Okay, so let me write here melting process. Here was only ice, here was water, and here boiling. After boiling, it changes into steam. So at which points have the ice completely changed state to water? This is at end of boiling, at end of melting. So at end of melting, it's option like 2. Okay, so completely change is at 2. Completely change into steam. Steam mean at end of boiling. At end of boiling means 4. So 2 and 4 are the right options. It's D. We proceed to question number 17. Water, okay, with this the thermal physics finishes. Now from 17, waves will start. Water waves are reflected at plane of surface. Reflection. Dear students, not only the water wave, any type of wave, when they are reflected, there is no change in speed, no change in wavelength, no change in frequency. None of them will change. So if only something changes, it will be. So no change in frequency, no change in speed, no change in wavelength. So reflection means if a water is coming this way, after hitting it will go that way. So it means direction will change. Direction will change. So option is A. We proceed to question number 18. It's a refraction of light. So a ray of light is passed through air, glass, and water. At which points does the light speed decreases? Speed of the light decreases when it goes from less dense to dense medium. So let's see which one is less dense and which one is denser medium. Air is less, glass is denser. Yes, speed will decrease. You can say even the angle is decreased from normal. So glass certainly is one option. After that, air to water. Also speed will decrease. So this is the second point. So they say at what points? So you will choose the point W and point Y W is air to glass, speed will decrease, and Y is air to water, speed will decrease. The option is B. Very easy. We don't need any calculation. We proceed to question number 19. This is diffraction. Diffraction is spreading of waves into geometrical shadow. So plain water waves approach the narrow gap. Which diagram shows diffraction pattern occurs? Okay, let's discuss one by one. Option A, you can see this gap size is almost same as wavelength. So there should be maximum diffraction. So maximum mean like that. So they didn't give you that way, so option A is wrong. B is completely wrong because initial wavelength is not same as final wavelength. They are not equal. They have to be same wavelengths. That's why B is wrong. We check the option C for question number 19. C, my dear, look, wavelength, same. If gap size is same as wavelength, it's properly spreading. Option C. Let's see what's wrong with D. D, double mistake. Neither the wavelength is same nor the spreading is taking place. So D is also wrong. The option is C, my dear students. We proceed to question number 20 now. 20 is again refraction of light. Let's read the question well. A ray of light enters the transparent plastic wedge from air and incident on lower surface at the critical angle. Now at critical angle mean there will be total internal reflection. Sorry, at critical angle mean the light will go along the boundary at 90 degrees. Okay. So this one is critical angle. Okay. Now students, question is the angle of incidence I is I, angle of refraction is R, and critical angle is C. In which diagram they are labeled correctly? No need to read. Let's go here directly. So incident is the incident ray, this one, I. Angle of refraction, as you can see, it is with the refracted ray. Critical angle is when the light goes along the boundary. So I, R, C. Which option matches? I, incidence, R, refraction, C, critical angle. Option is B. We proceed to question number 21. It's also optics about the lens. An object is placed 20 centimeter in front of thin converging lens. The scale diagram shows how lens forms a real and inverted image. You can see it's upside down, inverted image. And you know real image is always inverted. Virtual is upright. You can learn revu, revu. Real always inverted, virtual upright. Revu. Real always inverted, virtual always upright. Okay, anyhow. Which row gives the focal length and the distance of image? Focal length is when a parallel ray crosses the principal axis, that point is focal point. Here is a parallel ray and it crosses here. So this point is focal point. So my dear students, first label this as F. Label this as F. So now you want to know how many centimeters is the focal length. You can take the scale. Scale, they are saying this one is 5 centimeters. So it means each small line will be how much? 0.5. So let's go. Focal length you will take from the center. So 1, 2, 3, 4, 5, 6, 7, and 8. 8 small lines are there. And I told you each small line is how much? 0.5. So focal length will be 0.5 multiplied by 8 small lines. If you multiply them, that's 4. There is no other option. So we don't need to look what is the distance of distance. Once you found the focal length, you can choose the option A, my dear students. We proceed to the question number 22. Electromagnetic spectrum. The radio waves are electromagnetic waves. What is the wavelength of the radio waves? Wavelength means lambda. Frequency you have. You know radio waves and all electromagnetic spectrum, their speed is same as speed of light, which is 3.0 10 power 8 meters per second. You will make this triangle if you are feeling difficulty in rearranging. So V is equals to F times lambda. From here, the lambda will be V over F. V, the speed you have to memorize, it is 3.0 into 10 power 8 over F, frequency 2.0, 10 power 5. When you divide them, 3 divided by 2, 1.5, 10 power 3 will be the answer. So 1.5, 10 power 3, which is 1500. Option D. Easy question. You just needed to know that the electromagnetic radiation, their speed is 3 into 10 power 8. You put the wave equation, you get the answer. We proceed to the question number 23. A candle flame is placed in front of the loudspeaker. Loudspeaker gives you, my dear, sound. Sound waves are longitudinal. And longitudinal waves, look at the source, they vibrate back and forth like that. So when the waves, they cause the vibrations back and forth, so it means flame will also oscillate back and forth. Option either C or D. And I told you the nature of sound is longitudinal. The right option is C. Now we proceed to question number 24. With this, waves finish. Now we proceed to the question 24. So electricity and magnets will start from here. Diagram shows a part of magnetic field around a strong magnet. Which position does the magnetic pole experience strongest force? Strongest force means the lines are closest. The lines are closest. When lines are closest, it's the strongest force, and strongest force is always on poles. So option is A. We proceed to the question number 25. The current is 0.6 amperes. You can give the letter I for current. I is current intensity, so I. How much charge? Charge symbol is letter Q. You want to find. And the time. So time, there is a trick. It's given in minutes. You can't use minutes. You have to multiply minutes by 60 to change seconds. So 2.5, you multiply by 60, it is 150 seconds. So you want to find charge. You can write the current equation, as you know that the current is charge per unit time. So charge will be current multiplied by time, which is current how much? 0.60. Time is 150. You need to multiply these two. The answer will be 90. Option C. Very easy question. We proceed to question number 26. Which two physical quantities have unit joules per coulomb? Actually, my dear, joule is energy. If you say like this, joule per coulomb. Joule is energy or work done over charge. Coulomb is charge. So energy per unit charge, it is actually PD, it is EMF, it is voltage. So check which option is aligned. Charge and energy, no. Charge and potential difference, charge no. EMF yes, PD yes, option C. EMF yes, charge no. So this is the unit for EMF and potential difference, option C. We proceed to question number 27. A copper wire is placed in an electrical circuit and its resistance is measured. The wire is then placed with a second copper wire with the twice length and quarter diameter. Okay, so first of all, let's make the relationship of resistance with the length and with the diameter. We will make the table. Resistance is directly proportional to length. So this means length resistance. So if length is multiplied by 2, resistance will also be multiplied by 2. Okay, first concept is done. Now diameter. Resistance is inversely proportional to square of diameter. What does that mean? That means if here resistance, here diameter. Okay, let's change opposite way. Here diameter, here resistance. So if diameter is quarter, quarter diameter means, so diameter is divided by 4. So it means resistance will be multiplied by 4 square. Why? Because square relationship. My dear students, take them out. Take both of them out. Which two? This and this. So overall your resistance is going to be due to length and due to diameter. So resistance will be times 2 and times 4 square. So new resistance will be 4 square, 16 times 2, 32. New resistance will be 32. So the ratio of the resistances will be 1:32. So before was 1 R. Now 32 R. So 1:32. Option D. You should watch this question again. It's an important question. 28. Question number 28, my dear students. Which circuit contains a diode connected to series with fixed resistor? So first of all, learn, my dear students, diode symbol is a triangle with line. Fixed resistor symbol is a rectangle only. So this one is not diode, it is LDR. This one is thermistor. This one is variable resistor. This is diode and resistor. Option C. And D is variable resistor with diode. So the right option is C. This is a very easy question. After that, question number 29. In the circuit shown, the resistor X has twice the resistance of resistance Y. You can write, so if this is R, this is 2R. Which statement about the circuit is correct? The current in the cell is greater than the current in X. Now current, my dear students, in the cell means this current. Of course, this current is greatest. Why? Because this has to be distributed here. So I don't think so. We need to read the other options. Because the cell provides a total current and in the end it will be distributed. The current in the cell is certainly greater than both. So cell current is more than X. Cell current is also more than Y. Why? Because the cell current is actually current of X plus Y. So option is A. That's an easy question. We proceed to question number 30. A 4 ohm resistor R and 8 ohm resistors, you can say R2 and R1, are connected in series. Okay, let's connect them. 4, 8, connected in series with the power supply. Here is a power supply. A voltmeter is for 8 ohms. Here there is a voltmeter. And this reads 36 volt. What is the voltmeter reading for other one? So this one will be how much? Easy. You can do crisscross because potential difference is proportional to their resistance. So you can say the 8 volt 36, 4 volt, sorry, 8 ohms 36 volt, 4 ohms how much? So if resistance is half, the voltage share will also be half. So half of 36 is 18, option B. We go to question number 33. A metal rod XY is placed in a magnetic field so that it is perpendicular to the field. Okay, this is the metal rod, this is the magnetic field. Okay, in which direction the rod is moved so that there is a current from X to Y, induced current. My dear students, whenever you have induced current, the word induce is the key word for you. So you have to use Fleming's right hand rule. So let's apply Fleming's right hand rule. Current is Y to X. Y to X is the current. Magnetic field is this way. And okay, so I will just use a thick color magnetic field. And here is the current. And now let's apply Fleming's left hand rule. See here, my dear students. Fleming's right hand rule, I mean. So right hand rule says, you can say father, mother, child. Father, mother, child. So, or mother, father, child, sorry. Motion, field, current. Mother, father, child. Mother, father, child. Okay. So motion is the thumb of your right hand. Field, magnetic field is the index finger, and child, current. So what you have to do, first of all, adjust the magnetic field. Magnetic field finger is this one. So adjust towards your right. So take the hand towards your right this way. Okay, now current is keeping this index finger to your right side, you will make the current up. So like that. So index finger is towards your right, the second finger is the top of the page, so the thumb is facing your eyes. So thumb will be facing your eyes right now, thumb is facing my eyes, so it is out of the paper. So you will choose out of the paper, my dear students. So 31, I just explained you, out of the paper. Fleming's right hand rule. After that, question number 32. It's about DC motor. So the diagram shows a basic electric motor. What are the names of features like X, Y, and Z they want? So as you can see, the X is coil. Z is either you can say split ring or you can say commutator. And Y, this is brushes. The Y is brushes. So X coil, Y brushes, and Z is commutator, option B. Easy question. We proceed to question number 33. Two transformers P and Q each has 200 turns on their primary and 1000 turns on their secondary. Both are 100% efficient. The secondary, okay, so first of all, two transformers I will quickly make. This is the first transformer, second transformer. So they both have primary turn 2000, secondary turns 1000. Other also, primary 2000, secondary 1000. Okay, both are 100% efficient. Secondary of transformer P is connected to primary of Q. P, Q. So they are connected here. Like that, okay? Q provides a motor with current 0.2 ampere. So here output current is 0.2 amperes. What is the current being supplied to the primary of them? Now it might be a bit complicated question for you, so let me help you, my dear students. So first of all, you know some equations. The number of turns with currents, all equations I will write for you. Vp over Vs is Np over Ns. Also, you should know Vp over Vs is Is over Ip. So first of all, we will talk about the voltages, like what happens to the voltage. So over here, my dear, from here to here, the voltage is stepped down. How much? By half. The voltage is reduced by what? Half, my dear. Again, this voltage comes here. Again, number of turns are half, so voltage is again reduced to half. So overall voltage is reduced to quarter. Yani you can say divided by 4. Okay, now you know using this equation, voltage ratios is opposite to current ratio. So if voltage is stepped down, then current has to be stepped up. So stepped up means this is more current. This is what? More current. So this is more current means what? This input current here was less. So if this goes more, like times 4, so it means the back was less divided by 4. So what will you do? You will do 0.2 divided by 4, 0.05. I want you all to watch this question again carefully. If you understood, that's great. So what do we do? The voltage is, again, please watch everybody, just like a summary. From first transformer, primary to secondary, the voltage is divided by 2. Again, from here to here, voltage is again divided by 2. So this means the overall voltage is divided by 4. If overall voltage is divided by 4, so it means overall current this way is supposed to be multiplied by 4. So it means output current is 4 times more than input. So if output is times 4, so input will be divided by 4. It's a good question, and you should come back and watch this again. We go to next question 34. Question number 34. Now with this, the electricity is finished. We go for nuclear physics. Alpha particles are directed to a metal foil. Most of the alpha particles through the foil with the little change in direction. So we know most of them, they pass straight. Why do they pass straight? Because, okay, there is another option. So most of them, they pass straight. A small proportion of them are scattered back. What does this evidence tells you? So this evidence tells you that the nucleus, very small, nucleus is positive, and nucleus contains most mass of atom. This is Rutherford's model. So let's see which option has this set of information. Okay, so what does it tell you about the structure of atom? It consists of charge center, yes. Much smaller than the size of atom, yes. With little mass, yeah, this is the problem. I crossed. It contains most mass. B. They say atom consists of negative charge. No, also wrong. Atom is neutral. It didn't tell you anything about negative. Option C. It consists of a charge center. Yes. Much smaller than size of atom. Yes. But contains most mass of an atom. Yes. Option C is the right answer. Let's see what's wrong with D. It consists of positive charge. Yes. Positive charge. The size of atom. Okay, negative charges scattered through. It didn't tell you anything about negative charges. So option is C, my dear students. We go for question number 35. Which statement correctly compares the properties of alpha, beta, and gamma? Let's read, and I will tell you which one is right, which one is wrong. Option A. Alpha particles are less penetrating. Yes. Than beta. Because alpha are less ionizing? No. Alpha are most ionizing. So A is wrong. B. Alpha particles are less penetrating? Yes. Because alpha are more ionizing? Also yes. Alpha particles are more penetrating? No. More penetrating? No. The most penetrating are gamma, then comes beta, and finally alpha is the least. We go for question number 36. Which statement about alpha decay is correct? Okay, so let me tell you alpha decay. There is a parent element X which has proton number Z and nucleon number A. It gives you alpha. Alpha is 4, 2. And then gives you a daughter element which is Y. If you balance, so A minus 4 and Z minus 2. So the element which is formed have 4 less nucleon, 2 less protons. So nucleus loses electrons? No, it didn't lose an electron. It lost 2 proton and 2 neutron. The nucleus changes to that a different element? Yes. Why different element? Different element because different number of protons. Let's see what's wrong with C and D. Nucleus does not decay until one half-life. No, it has nothing to do with that. After two half-life, it stops. No. After two half-lives, it will be 25% rate of decay. So option is B. We proceed to question number 37. Half-life, always interesting question. I want you to revise this again and again. An explosion in a nuclear reactor spreads the isotope of cesium 13755 across the large area. After 90 years passed, the quantity of cesium is only 12.5%. What is the half-life? Okay. So after 90 years mean total time. What is the half-life? Means T half. Let me give you a relationship between them, how total time is related with half-life. There is a formula which I made. It says the number of half-life periods is total time over half-life. So if you want the half-life, my dear students, it will be total time over number of half-lives. To find the number of half-lives, you make a decay sequence. Decay sequence mean now remaining is 12.5%. So it means initial was 100, then you divide by 2, it became 50, then you again divide by 2, it became 25, you again divide by 2, it became 12.5. Okay, so to reach 12.5, how many half-lives? 1, 2, 3 half-lives. So it means n is equals to 3. This n3 you substitute here. So the total time they gave you, it is 90 divided by number of half-lives 3. The answer is 90 divided by 3, 30 years. So 30 years, the option is C. I want you to rewatch the solution. It's also an important question. So far, I have put 3 stars. You all must go back and watch these 3 questions again. Our next question is which type of object rotates? With this, the nuclear physics finishes and we enter the space physics. So, space physics, first question is which type of object rotates around the sun with an elliptical orbit? So, around the sun, planets, galaxy, red giant, moon. Planets rotate the sun, okay? Galaxy doesn't rotate around the sun itself. Galaxy is itself a collection of stars. Red giant is a sun itself is a dead stage of a sun is red giant. No. Moon they orbit planets. Moon orbit planets. So option is A. If there is no option of planet, it could be a comet as well. So option is A. Which statement about the sun is correct? Let's read and we'll tell you which statement is right and which one is wrong, my dear students. Nuclear reactions in the sun create mainly radio waves and micro. No. They are is very ugly. 3 radiation. Is mean infrared, very mean visible light, and U mean ultraviolet. These are the 3 main, so that's why A is wrong. Now let's go for option B. Sun is powered by fission? No. Sun is powered by fusion. Okay. Sun is powered by fission? No. It is fusion of hydrogen. Also wrong. Option D. The sun is powered by fusion? Yes. And electromagnetic radiation are produced? Yes. Option D. You know heat. Heat is produced. Heat is actually infrared. Plus visible and ultraviolet, mainly these radiations are produced. Others are with low intensity. Question number 40, last question. To determine the value of Hubble's constant, an astronomer measures the distance of galaxy from Earth. This is distance of galaxy, but make sure it is in kilometers. She also measures the speed of recession of galaxy is v. From this data, what is Hubble's constant? Your learning objective says you should memorize a number. This is Hubble's constant. So if you memorize, you can easily choose option B, but you know Hubble's law. Hubble's law says V is directly proportional to D, so V is H naught D. V is H naught D. So H naught is V over D. V is 5.2 into 10 power 3 kilometers per second over 2.5 10 power 21 kilometer. I didn't change kilometer because both will cancel. So answer is 2.1 10 power negative 18 per second, option B. Okay, so with this we finished the variant 1. Wait for the variant 2. Let me tell you, this paper had 3 to 4 challenging questions. Overall, this paper was fine. Challenging questions, I encourage you to rewatch. Thank you. Take care. Bye-bye.